Let's start with the little FN plot. The little FN plot is the most used and one of the easier portrayals to understand. It is one of the primary considerations used when assigning dam and levee safety action classifications. The x-axis is the average incremental life loss, N bar, and the y-axis is the annual probability of failure. The diagonal lines, which are the product of the APF and N bar, show the average annual life loss. On this plot, we will plot the marginal or unadjusted risk of each potential failure mode and then the total project risk. The reason we adjust failure modes is to avoid errors such as double counting when we combine them, so the adjustment only impacts the total project risk. In this example, the highest risk failure mode is PFM2B, even though it has the lowest APF of the plotted failure modes. The risk is represented by the diagonal lines, as it is the combination of both probability and consequences. Risks are unacceptable when the average annual life loss is greater than or equal to 1 times 10 to the minus 3, except in extraordinary circumstances. For levees, things are a little different. The average annual life loss must either be at least an order of magnitude less than the average annual non-breach life loss, or be below the standard average annual life loss guideline of 1 times 10 to the minus 3 lives per year, whichever is higher. Risks that plot in the bottom right-hand portion of the plot with an annual probability of failure less than 1 times 10 to the minus 6 and life loss greater than 1,000 are referred to as low probability, high consequence events. Estimated risks that plot within this region deserve special scrutiny during the decision-making process because of the magnitude of the expected consequences. We will talk more about this later. Next, we have the big FN plot and the big F dollar plot. These are probably the least understood of all the required plots that are used. The big FN plot displays a probability distribution of incremental life loss from all failure modes and all population exposure scenarios for all inundation scenarios associated with incremental risk. This curve is like the flood hazard curve or the seismic hazard curve, but with the axes flipped so that the probabilities are on the y-axis. You can think of this plot as a frequency curve for consequences. The big FN plot is essentially a complementary cumulative distribution function. The only difference is it shows the probability of being greater than or equal to a given life loss. This plot answers the question, what is the annual probability F of incremental life loss greater than or equal to N? To use it, pick your incremental life loss magnitude of interest. Draw a line straight up until you reach the curve, then draw a horizontal line to the y-axis to get the annual probability of having at least that number of fatalities. For this example, the estimated annual probability of 300 or more fatalities due to dam failure is about 1.2 times 10 to the minus 5. Both the little FN plot and the big FN plot have a region in the bottom right-hand corner for low probability and high consequence events. Estimated risks that plot within this region deserve special scrutiny during the decision-making process because of the magnitude of the expected consequences. When estimating probabilities, there is a lower bound beyond which the reliability of the estimates becomes questionable. There's also a threshold beyond which the magnitude of consequences necessitates extraordinary measures to control risk. Because of this, it is appropriate to treat low probability and high consequence situations with great care and closer scrutiny to ensure everything reasonable has been done to reduce risks. This region is defined by life loss, average incremental for the little FN plot, and just incremental for the big FN plot that is greater than or equal to 1,000, and an annual probability of failure less than or equal to 1 times 10 to the minus 6. We also have a plot for the individual most at risk. The individual life risk is represented by the probability of life loss for the identifiable person or group by location that is most at risk of life loss due to a dam or a levee breach. It is influenced by a person's location, exposure, and vulnerability within a breach inundation area. The individual risk is calculated as the annual probability of failure times the likelihood of the most exposed person or group losing their life. The second term in the equation will be provided by the consequence specialist. The individual life risk limit is 1 times 10 to the minus 4. The individual risk will always be less than or equal to the annual probability of failure. So if the APF is less than 1 times 10 to the minus 4, then the individual risk will also be less than 1 times 10 to the minus 4 and below the limit.